Welcome, guys. Today, my name is Cedar Birdsall. I'm going to be giving an informative speech about how plate tectonics work. And I want to start off by just allowing you guys to kind of conceptualize the idea of plate tectonics and what I might be talking about here in this speech. But anyway, I want you to think of Earth as a giant egg that has cracks running through the whole egg, and each shell is cracked and divided. It's divided up into a bunch of different egg shells, but still whole egg. And how these plates move with each other and interact with each other. I want to talk about that. And I don't know, I'm super passionate about this subject. I'm in an earth science class right now, and it's really interesting, and I want to talk more about it. Anyway, we're starting out with understanding Earth's layers is the key to understanding plate tectonics. So, starting off, you got the crust, and that's what we're standing on right now. And then right under the crust, you got the mantle, and that makes up the lithosphere. And the lithosphere sits right on top of the asthenosphere, which is a almost Play-Doh-like kind of texture. It's it's ductile, not completely liquid, but it's also not completely solid. So in this asthenosphere, you have convection cells, and these convection cells are from the Earth's core. They heat up that ductile material, and it flows up, and then as it flows up, it cools, and then it comes back down, creating a convection cell. And these convection cells are basically the engine of plate tectonics. It's what allows these plates to move. We are standing on the Pacific plate right now, and just our neighbor, let's see, I think that way is the North American plate. But these plates, their interaction with each other shape the world around us, and they're super important. So I want to talk about the different types of plates and plate boundaries specifically. So say you have two tectonic plates, and we'll start with a divergent plate boundary. Divergent plate boundaries are when two tectonic plates are moving away from each other. And this, you can see evidence of this at the Mid-Atlantic Ridge, which is the North American plate and Eurasian plate pulling away from each other. And what happens at these divergent plate boundaries is, if it's oceanic crust pulling away from each other, then you're going to have molten coming up from the asthenosphere, moving through the mantle, and then cooling once it hits the water, forming these mid-ocean ridges. And as they pull away like this, it basically is, or seafloor spreading, but the Atlantic Ocean is growing as we speak right now. The plates are pulling away from each other, new magma comes up, it cools, adding new material, and it keeps pulling away and pulling away. Next major plate boundary is convergent plate boundaries, and that's when two plates are coming together like this. So, and this is highly dependent on what happens is highly dependent on what type of crust are interacting with each other. So if you have continental and oceanic crust colliding with each other, then the oceanic crust is more dense compared to the continental crust, almost like the continental crust. You can think of it as hot chocolate, or you got the hot chocolate, which is the atmosphere, and then you got the crust, which is the marshmallows sitting on top. Anyway, the oceanic crust, once they interact, they converge on a convergent plate boundary. Oceanic crust subducts, creating a subduction zone. In certain signs of a subduction zone, you're going to have deep ocean trenches where that subduction zone is getting subducted underneath the continental crust, and you're going to have volcanic arcs parallel to that subduction zone on land. Because once that oceanic plate goes down, once it hits the asthenosphere and heats up, the rocks get dehydrated, releasing liquids, volatiles, water, which lowers the melting point of the rocks in the continental crust, which allows magma to flow up. And then you got oceanic colliding. Same thing. It's gonna denser, older oceanic crust is gonna subduct underneath. You're gonna have basically the same evidences. When two continental crusts collide, it's mountain builders. So you got results like the Himalayas. Last one is going to be transform plate boundaries. And these guys are shearing past each other. Like this. So you got one plate right here. And you got the other one sliding past. There's no subduction or pulling away. They just slide past. It's shear force. And one famous example of that is the San Andreas Fault. And that's right next door. That's actually what separates us from the North American plate. It cuts Santa Barbara off. And anyway, that's my talk about plate tectonics.